Esposito and
Tony
Jason.
and Jason. Yes, geez, I'm running out of paper here. Okay, Tony.
All
Tony
right,
Esposito
Mike.
and Jason. Yes.
In 5,
Oh,
4,
Jesus. Yeah.
3,
Yeah.
2, live.
Welcome back, folks. We're here at the IES convention or conference 2019, and we are live streaming. We're going to talk a little bit about TM30 and some of the incredible things that went on in that room right there. But before we do, we got to tell you a little bit about our friends at Kurtzon Lighting. Go to KURTZON.com, baby. That's kurtzonlighting.com. Specification grade, over 100 years old, longtime IES member, almost as old as Canada, Greg.
That's right. And the fact that this really defines how specification grade they are. They have behavioral health offering. That's a whole product line. It's one of the select few manufacturers that actually has it. Published in the Office of Mental Health in New York as approved to be used in these applications. UL or ETL does not have a standard or listing yet regarding anti-ligature, but they do. And they have fixtures that you'll see online. Again, another example of how specification grade Kurtzon really is. They have a behavior health product line.
Yeah, you know what? They also make like what people talk about.
They do.
Yeah, you know what I'm saying? Like there's a lot of talk about stuff, but Kurtzon actually makes it too. So folks, if you're listening to this and you need specification grade quality, you're live calling and get your crap together, go to KURTZON.com, baby. That's Kurtzon.com. Welcome, Tony and Jason.
Good. Thanks for having us.
Thank you.
You got to move that mic a little bit closer to your mouth there, Jason. A little bit more. Tony, sorry.
Tony.
Yeah,
There we go.
Yeah, there we go.
Great.
Okay, so how did you guys conceive of that? That room, that demo room was pretty special.
Oh, thank you. I appreciate that. So I'm on the conference planning committee, and they had some ideas for some demo rooms, and I thought people really need to see this stuff in full scale and experience it and be inside of it. We talk a lot about numbers, and we can match the numbers to perception, but it's seeing really is believing. So I had the idea that people really need to be in a room full scale and see and experience these things.
So what's in the room right now for the listeners out there is it's like a shelf on a grocery store of all the food. So my question is, who gets the food?
I want those cheese nips, man.
Those Ritz crackers and the Doritos, they all look good.
But you know what's funny? I think it was we just were speaking to Brian and Tom just moments ago, and I think the first thing is that people need to know that CRI is going away. Like it's being replaced.
Let's hope so.
No, but I think a lot of people don't know that yet.
Yeah.
Like there's a lot of people out there that don't know that. And you may think from your perspective, and I don't know what you guys do every day in terms of your business, but from the distributor side, I think most distributors are still pretty much into CRI.
Yes.
And contractors are, CRI is the answer. What's the CRI? CRI is 92. Well, that's amazing then, right? Well, if you looked at that RFRG stuff you were showing us with the different saturations and all that, that's some pretty fun stuff. And it's certainly a lot better than CRI.
So can you break it down for us, like what this new standard is for the average lighting dork like us?
You want to explain this? Is that helpful? We can throw that up on the screen for the listeners if you want.
Sure. If you want to
start off with that.
Hey, Scott, if you want to throw this little document up, it's the one that's called the design intent. And there. Tony's going to go ahead. It's up there. So they're seeing this now. If you want to go ahead and talk about it.
I think the first thing to lay out there is that since 1965, when CRI was unveiled, color rendering has been synonymous with color fidelity because that's the only metric that we've had is a fidelity metric. But color rendering as a concept is a much bigger umbrella, right, that has other things underneath it. And one of the great things that TM30 has given us is the ability to take these calculated values and, as Tony says, map them to subjective impressions so that we can now evaluate a light source for the way it renders colors with different design goals other than just fidelity.
That's right.
Right.
Yeah. And so TM30 is really meant to be an objective system of measures, insofar as we can call them objective, right? They're based on human vision. So it's a system of objective measures that we use to try to predict visual experience. And so we can combine these metrics in different ways to predict what you're going to see and how it's going and what you're going to like and dislike. And that's the table that the viewers are seeing now. This is the latest work from the IES Color Committee. This table it's a recommended specification guidance.
Table E2 design intent.
That's right.
Yeah.
And so for people who find that okay, TM30 is out there, it's really complicated, I don't fully understand how to use it, this table says, okay, if you want to achieve a light source that creates objects that are preferred, a preferred visual experience, then the P1 is the way to go. You want to try to get a light source that achieves those values, and the likelihood that your source is really highly preferred is going to be really high. Now, as you decrease, you get a P2 or P3, or even off of that, there's lower and lower likelihood that people are going to prefer that light source. So so this table is really just trying to make it easy for specifiers and manufacturers to design and specify light sources for various goals.
Preferred is an interesting word.
Well,
I
Who
agree.
chose the word preferred?
I'm not sure where that came from.
Probably the first.
Because I get vividness, I get fidelity. Those are
Mhm.
those are not, they're not obvious, but it's an obvious why you would use those words.
It comes from the research where you can show people a room full of objects, change the spectral power distribution of the light, and ask either general response, what do you think of this, or ask a more targeted question. And one of the things that has come out of that research is that high fidelity is not necessarily most attractive in a lot of situations. And
That's
the key,
interesting.
and the key to
Why
that
is
is,
that?
well, the key to that really turns out to be
When you
that
say, just for the listeners, what do
Yes.
you mean when you say fidelity? Let's just get that out of the way because not everybody knows what you mean.
okay. When we talk about fidelity, we're talking about taking a light source that we have, matching it to a reference standard light source. So when we say that a light source has high fidelity, it means that the light bulb that we've just invented, when we match it to a reference source, is a very close match.
So could that be CRI in another way?
That is CRI.
That is
CRI is a
CRI.
color
Fidelity
fidelity
is CRI.
metric.
Okay.
Exactly.
Yep. Okay.
And the parallel in TM30 is RF. RF is the TM30 color fidelity metric.
Okay.
And when you say vividness, what do you mean by that?
So so you can show that that light sources can change how vivid or the saturation of objects, and as you increase the saturation of those objects, our perception of vividness also increases.
Like an orange turns super orange, almost red.
Yeah,
Yeah,
it gets almost
exactly.
oranger.
Yeah. Exactly. Okay.
And this scale is one better than three, or you said it doesn't necessarily mean that?
So one increases the likelihood that you're going to achieve that intent. So for preference, so if your goal is to create an environment that people really prefer, you want a light source that's P1. P1 is going to be the highest likelihood that it's going to create that. A P2 is going to be less likely. A P3 is even less likely.
Now P1 includes the fidelity and the vividness.
So
No.
it's not mathematically
No.
possible to achieve a P1, a V1, and an F1.
Ah,
So
I see.
and the reason for that is because you can linearly increase your perception of vividness almost infinitely, right? But if you ask people if they prefer those light sources, they start tapering at a certain point. So there's a certain level of increase in saturation that people say, okay, now this is too much. It's almost cartoony, right?
And we saw that with the
That's right.
nips almost looking like they're jumping off the box.
That's
It
right.
looks a little creepy almost.
Right, that's right. So you can increase perception of vividness starkly and forever, but at some point people are going to go, oh, I don't like that anymore. And so
Sure.
so there's a plateau effect between preference and vividness. And so if you look at the actual numbers, to get a vividness of 1, you need RCSH1, which is chroma shift in red. You need greater than 15%. That's a lot of red saturation. But at that level, you will no longer qualify for a P1 because it's too high. So go ahead.
So what you've
I'm
got
just-
now is what you have is 3 separate and distinct design intents, right? I want high fidelity, so colors are not being distorted relative to my reference light source. I want preference, that is to say, I'm permitting some level of color distortion, and I want that color distortion to go in a way that most people like better than high fidelity. And then we have vividness, which is I want to deviate from high fidelity, but I want to do it in a way that makes colors more vivid, more saturated,
Yeah.
brighter. Right.
I can't remember.
And so, well, so then, just sort of to get
Yeah,
back
sure.
to what you asked, it could be that in some applications, I have only one goal. Right. Let's say in healthcare, perhaps my goal is high fidelity.
Yeah, you're
right?
almost answering my next question.
And
Keep going.
but in another situation, let's say retail,
Sure.
it could be that I'm interested in both preference and fidelity.
Yeah.
Or perhaps I'm interested in preference and vividness.
Or
If I'm
maybe
selling- if
I'm
I-
designing a candy store in Times Square,
Yeah,
and I
sure.
want people to come in off of the street because they
Oh,
see
be
really
loud, man.
vivid
Yeah.
colors in the window.
Exactly. So
There's your
I was
vividness.
in there and I was thinking, this is what I wrote in here. My notes: selling in a space versus being in a space.
Mhm.
So if you said to me, which space would you want to be in, like hanging out with my kids or whatever, I would have chosen one of the lower saturated levels, like slightly lower. But if I was going to sell those Reese cups that you had in the top corner,
Sure.
there was one level that they just look spectacular in. Like really, like you changed it from
That's
one.
right.
It was a very minor shift. And I actually preferred for me being in the lower or the less saturated one. But when you looked at those Reese peanut butter cups or whatever, man, did they ever look better in that one
Right.
light? Like it was really, really good to look at. Now, maybe there's something wrong with my eyes. Maybe other people prefer it. But if it's just me deciding, I think you're going to sell a heck of a lot more Reese's under that, the second whatever
I
preference.
think
it
so
was.
too. Yeah.
Like seriously, man, the package looked amazing.
Yeah.
No, I get
It looked like a different package.
Yeah. Lighting is powerful.
It is. It is powerful.
I get the need for the metric, and I think it's important, but bringing it to where we are every day, which is selling light bulbs to businesses, offices, are they going to
Hotels.
care about this at all?
Well,
And who's yeah,
I think your lighting designers will care.
for sure then?
And your lighting designers, one would like to think, have the trust of their clients.
Yeah.
And can explain to them that, there is a great deal of research about things like the benefit of higher quality lighting. Reduced absenteeism, increased worker retention, and I'm not an expert in any of that, but one could make that kind of an argument, I think.
Well, I could go either way with this one, but I'm going to say this: isn't it? Doesn't it tell you where the industry is at and how the winds have shaped us? That they're having a conference on this. I think they said in April or June next year on non-energy benefits of lighting. Like the fact that you have to call it that, right? Like you have to call it. We're not talking about energy efficiency, okay? Like the fact that's the most exciting thing I've seen in lighting, maybe in my career.
Yeah. So I mean, energy efficient. Nobody's arguing that we should try to reduce our
Sure.
environmental impact and that we should
course.
reduce the amount of.
But you know what though? It's
energy
the pressure's been on the lighting business for 20 years. You know what? Why don't you make clean energy now?
Yeah,
We've
sure.
done everything we
Yeah.
can do. You know what I mean? What else is there left? We're going to go from a 12-watt LED tube to a 9-watt. I mean,
Well, I've been trying to make that argument for a while now. That we've gotten to a point now. Like, what's the point of 1 or 2% increase in efficacy when we're already consuming fewer watts than we've ever consumed? And so
the lighting industry's done its part when it comes to energy.
I think so. I think LEDs have really made a great stride to reducing our energy consumption. And if at this point now the big goal is converting buildings that use old technology to the new technology, that's where we're going to get the biggest savings, I think, instead of trying to strap 1 more lumens per watt out of the light sources that we
Yeah,
use.
I mean, you saw that really from different accreditation agencies. That chase after the lumens per watt was so intense. And they compromised a lot of quality. They created a lot of glare. I mean, the whole street lighting thing. I'm not saying this, but we had someone come on our show, the Get a Grip on Lighting podcast, and say complete disaster street lighting. I'm not saying that, but there's a lot of bad street lighting, LED street lighting.
A lot of bad street lighting.
And you got, like lighting people can just see it when you drive around.
Yeah, just glare bombs.
Yeah. Oh, that's
down the
glare
street.
bombs. Yeah, for sure.
But I'm trying to relate this to practical. Okay?
Yeah, me too.
Lighting designers, I get it.
Like
Like when here's a
Schmiders.
new building, we're going to make it look sharp. All this.
Sure.
Now I've been in this building for 30 years, and I need a replacement light bulb.
Well, so what we really hope
What do you
to be-
want?
well, so sure.
That's a-
we hope that this will actually make it easier, right? So
Sure.
sure, the contractor wants they want simple, right?
Yeah, yep.
And
Yeah,
and
you got to
s-
take it to the street, man.
Sure. And so if a lighting designer comes and says, "Oh, I want an RF of this and an RG of this and an RCSH one of this and an RFH one of this," and yeah, exactly, you've already glazed over.
Yeah.
But what if I said I want a P1?
Yeah, that
I want a
works.
P1,
Sure.
right? And so this makes it a whole lot easier. So you say I want a P1. Now you don't need to understand the metrics. The person who's making the light source or specifying the light source needs to understand those things.
Wouldn't there be one though? I mean, in general, that let's take a fluorescent tube or an LED tube now.
Sure.
Are they gonna
Be labeled P1?
all be in the same category, or are there going to be different
doubt it.
levels of tubes?
I think that you've got just in the world, right? So many different applications, so many different uses. I think that this perhaps can provide guidance to LED manufacturers who can say, all right, lighting designers are beginning to look at things other than fidelity. Here are some categories that come strongly, deeply researched and strongly recommended. Let's do some market research and see if our product line should include one or two products in some of these other categories. And potentially it opens up a whole new avenue of sales.
Does the P1, P2, this doesn't take into account Kelvin temperature, does it?
So these should apply pretty unanimously across color temperature. So you
So
can
that
have
experience, that preferred one, is going to be whether it's 41K or 3000K.
for the most part. So the research is showing that these color preference trends hold up across CCT, and that there may be small differences across CCTs, but really the dominating effect is the color preference, or the color rendition, especially once you're adapted. Once you're adapted to a light source, the color temperature has very, very small differences.
So if you adjusted those color temperatures in there, I would have seen the same effect on that Reese box.
So I think so long as you didn't see me make the change, because
Okay.
you see a visual of a quick change in CCT,
Sure.
and that sort of predisposes you to act a certain way. It may influence your judgment. Now, if I took you out of the room and I brought you back in, and then you didn't see this visual change, I suspect you would respond the same.
Just one more on this point,
Yeah.
if you don't mind.
Mhm.
What if you're combining this with daylight harvesting? How does that impact it? Does it impact it at all, or is there anything that's happening in that? Like you have skylights with the system. Would there be anything different?
That's a good question. I mean,
That's 4 beers today, buddy. 4.
You got 12.
Well,
to
so
go.
I think if you could design your building in a way that you have really high daylight penetration and you could turn your lights off, then do that.
Sure.
Right. And so how does
Yeah.
this work in relation to that? I mean, good design can solve a lot of problems.
Mm.
Now, we have there's this thing called the Hunt effect, right? And what that means is that our visual sensitivity to color changes as a function of light level. Okay. And so what that means is as you dim lighting in a room, you will see objects become duller.
Yeah, your
That's
girlfriend
because-
gets prettier.
Okay. And so this is important, right? Because light level impacts our visual perception of color.
Sure.
And so what that means is at typical indoor lighting levels, we're already sort of on the Hunt effect spectrum, which is to say that we're already experiencing the world more desaturated than we would if we went outside.
Mm.
And so the research is showing that people tend to prefer increases in saturation, especially in red, because we're already desaturated relative to the outside.
Mm.
And so if you have daylight coming into your space and your orders of magnitude higher light level, then you're already experiencing the world more vividly. And so I think from a daylight harvesting perspective, you want to make sure that you're trying to replicate the vividness of daylight. And so there's probably some interplay between how you deal with that at a lighting system level.
And the one exception to that rule would be if you wind up with tinted glass that's
Sure.
changing the spectrum of sunlight.
Or glazing or whatever they call that stuff. Yeah.
Mhm,
Yeah.
Exactly.
Huh.
Then you may wind up.
Thanks for making it more complicated.
Yeah, anytime. That's what we're here
That's
for.
what we could do that, no problem.
So I got to go back to my
Sure.
the primary light bulb we sell is a fluorescent tube or an LED tube now at this point. Okay, so right now there's an LED tube and then there's a high CRI LED tube. Those are our options, and then wattages and lumens and all that stuff in between.
Flicker
But in
free,
terms
blah,
of
blah,
color, it's standard and there's high. All right. Now what are we gonna have, like, you want a retail tube? You want an office tube? You want an education facility tube? Is that where you're going with TM30? Or is it gonna have, I'm trying to wrap my head around how many different options.
How are manufacturers going to incorporate this technical memorandum into their marketing and sales for their products?
Well, I'll answer the first part. Maybe Tony wants to do the second, but we are intentionally application agnostic in all of TM30. We're not telling anybody what values to use in a given application.
But the manufacturer could and might do that.
You know, manufacturers do already, right?
They do.
They say, look, buy this beautiful pendant fixture. It's ideal for lobbies.
Yeah.
I don't care what they think it's ideal for. But we're intentionally application agnostic. So
it's up to the manufacturers to take what you're doing and apply it in the marketing from a sales perspective.
And
work with the designers
and also
and the
it's up
design
to the
teams.
designers, right?
Sure.
To say, like, on this project, my design
But
goals
you know,
are
90% of light bulbs and lighting systems are not deployed with a lighting designer involved.
Yeah.
Maybe more than 90%.
Yeah.
We're hoping to change that.
I'm not.
We're not going to.
I'm going to keep it the same way because
but
no, but you know, it's so you know, so you take a big box retail store. You mentioned, I don't know how important it's going to be, but you know, certainly high-end retail, there's going to be definitely a lot after this. I don't know, Greg.
So I think I'm of the opinion. So to your point, right? You have two lamps. I'm sure there are plenty of applications where those lamps are just fine.
Sure.
Like color is not the most important thing all of the time.
In a parking garage.
Sure, and we're not trying to say that you should sacrifice everything in favor of color all the time, right? So a lot of these things are application specific, and so sometimes you just need something that meets a certain cost. You need something that has a certain light level. Color can sometimes be secondary issue. But what we're trying to show is that when color is a really important issue, there is a meaningful way to manipulate it to do different things. And so to your point, I'm not sitting here saying that this is color, this is always the most important thing, therefore what you're doing is unimportant. No, there's hundreds of applications where what you're doing is just fine. But there are some applications where color may be the most important thing. If you're lighting the Mona Lisa, color is important. You're not going to put, you know, a CRI 80 product there, or at least I hope you don't, right? And so it's not all of the things all of the time. So these things are application dependent, and color isn't always the first order problem.
Why is it named TM30? What does TM stand for?
Technical memorandum. We just found out, man.
Okay, but I mean, why 30? Just because it's number 30 in line? You had 29 and then you got to 30 and you said right now? That's it.
That's it.
Have a better name.
You guys are so come on, man.
It's an engineering society.
But there's no lighting engineers.
Yeah.
Huh? There's no such thing as lighting engineers.
No?
No.
Nope.
They don't have it. No, there's no professional engineering society that has a lighting engineer. Can't be a P-Eng lighting.
That's true.
Fair.
Right, you guys are an engineering society because the statement is that we're technically achieving stuff. That's what you mean when you say engineering society. That we're technically responsible to meet whatever we're doing.
Right.
But you can't graduate from whatever university or the University of Louisville with a degree in lighting engineering.
I have a degree in lighting.
Do you?
Yeah.
From where?
Penn State.
Penn State with lighting engineering.
It's an architectural engineering program with a lighting specialization.
You can't get a P-Eng lighting.
I mean, I don't have a P-Eng, so
I don't think so.
I don't think so. I mean, we're on the search for it. I'm open, right? I saw one person had a title called lighting engineer. I said, okay, great. Are you a lighting? No. My society, I'm an electrical engineer.
Yeah.
Right.
Well, there is. Perhaps it's changing. There is for the PE exam. There is a new test for architectural engineering.
Cool.
It's not specific to lighting, but has lighting in it. So maybe it'll change. Maybe it doesn't. Yeah, I don't know.
So no, I was going to say that I just want to change gears and just throw something out. I don't know. It may be out of your wheelhouse and what you've been working on with TM30, but is good lighting healthy lighting? Like that sense that well-designed space where you want to be and where you feel good or whatever. Is that what healthy lighting really is? And does that deliver the health impacts? I mean, how are we going to at what point do we stop trying to say, hey, if I shine these lights on people, they're not going to be sick as much, like, or whatever? Is it just good lighting design that we need with the right preference and the right spots, or where do you think the IES is gonna go with that? And am I off topic here with you
That
guys?
is so far outside my field of
Is it?
expertise.
Yeah.
I have thoughts and opinions, but no expertise on on that at
Okay, that's fine.
all.
On a live stream, that you know what that signals is I don't want to talk about this anymore. This is going right out there right now. That's what that means. No.
Yeah,
I think generally speaking that lighting is a hugely important part of our lives, right?
Mhm.
It's integral to a lot of us, and so in that general sense, I don't see how you could separate lighting from well-being. I'm not a
We're
well-being
children of the
expert.
light, man. We are light
That's right.
in a way. It's a spiritual, practical, technical thing that we're talking about when you're talking about light.
That's right.
It's artistic. It's technical. It's you know, there's all sorts of aspects to light that I think people take for granted in a way.
Yeah, I think from a scientific perspective too, it's much harder to measure good than it is bad. You could show a bunch of people a flickering light source and you can measure headaches, right? But will you get as definitive a response when you design a lighting system and you say, does this make you feel good?
Well, they know how
Right.
to design. They don't know. They know how to design brilliant systems of light using light to hurt people.
Hmm.
They know how to do that. Casinos have been doing that for years.
Hmm.
Shine vertical light at high Kelvin temperature, rarely brighten people's eyes, and they give you their paycheck. Right? They've known this for years. No, seriously.
Well,
It's a circadian rhythm disruptor at casino, right?
Yeah.
So they know this.
no windows.
What's the reverse? Yeah, no, and fresh air, oxygen. What's the opposite of that? You're like, maybe that's a good place to start. You know, what's the opposite of that? If there is one, I don't know. We're way out. It's live stream, so he's saying no deal. What do you got?
Back to TM30.
Back to TM30. Call again.
All right, so every light manufacturer, every lighting manufacturer is going to adopt this, you think, in place of CRI?
Well, no, it has to become a standard first, right? Before you guys really push it, or is it? Or is it
IES Team 30
No,
is a
we're-
standard.
Oh, it's
and
a standard now.
Yeah, and we're pushing it. The IES released a position statement earlier this year recommending that the industry begin to phase out the use of CRI and replace it with TM30. There are, some complications where there are regulations, for instance, that are specifically including CRI values, and so that's going to take some time to address. And maybe there. I don't know what kind of time frame we're talking about. 3 years, 5 years? 10 years? But I
somebody's
think
going
that
to
we're on
come
the
to our
way.
graves and look over and say thank you for putting this in place. It's finally been completed.
Change is slow, right?
Yeah.
I think what's important is that I asked, like, why do you use certain things, right? So like, why do you use a ruler? Why do you measure things, right? And every time you measure something, and you're building a deck or something, right? You measure something that's a foot, it's a foot, and you use that, and it's useful to you.
Sure.
Why do you use CRI? For what reason, right? Because below very high CRI values, any fidelity metric, there's very little parallels between the number and what you see, right? So if you're specifying a CRI of 80, why are you doing that? You can't, from that number, predict what the light source is going to do to objects. And so it's not a useful number to predict what you're going to see. And so you need more information. And that's what TM30.
It's actually a completely useless metric, actually, when you say that. Not completely, but almost completely useless.
Outside of very high fidelity,
sure.
there's no correlation between
741,
fidelity and what you see.
841, nobody cares. Nobody can see the difference between those two fluorescent tubes. An 841 or a 741. It's a 7.
So I mean, if you have a CRI of 95,
Sure.
RF of 95,
you can see it.
You know that what that's going to look like more or less. But the second you get below 85, right outside of the spec table, all bets are off. You have no clue what it's going to look like, and so you need the other metrics, you need the other information. And at this point, there is no other system that can do that. That's standardized anyway. And so for right now, this is the best we've got.
Tell the listeners where they can find more information about TM30, if they can go to the IES website, or where the best spot is.
It's a free download on the IES website. Probably best to just go to ies.org and then do a search in the
TM30.
search box. Type in TM30. It's free. So what you'll get is a zip file that contains a PDF of the standard and 2 Excel spreadsheets. One that we call a basic calculator and one we call an advanced calculator. both of which have an extensive library of existing light sources. And the advanced has a means of either importing or entering by hand the SPD of a light source that's not in the library. So you can, if you have the SPD of a light source, you want to know what the TM30 values are, you can find out.
What about the Ready Reference app? Is it on that as well? Can they search it on the app?
I've never looked.
Oh, we'll have to do it.
something
Better
we'll
figure
have to
that
check
out.
that
I think they
out.
probably have definitions on there, but
Sure.
they don't
Better
have,
to go to the IES.org and go from there.
if you want the standard and you want a means for calculating the values, then yeah, you should go to
cool.
the IES website.
And coming soon, we hope to have the calculator online.
Okay.
Probably on the IES site. So I'm not entirely sure how long we're going to need to get that together. But yesterday, Brian Liebel
Just talk to him.
just talked to
this
us. Yeah, Brian said, hey, why can't we do a calculator online? And we said, we thought you told us that was going to be too hard. And he said, that's not too hard. When can we get it done?
Time to get it done.
This is all news to me.
There you go. Folks, we appreciate you listening, and we're very grateful to you out there if you're watching this and enjoying our time with Tony and Jason here talking about TM30. It's a really wonderful time. I feel like we're pioneers landing on a new industry and getting our machetes out ready to enter the jungle, but this is pretty exciting, folks. So get into it if you're a lighting designer, if you're a light bulb seller like Greg and I. It's definitely worth Googling or searching for TM30 on the IES website. And of course, Greggy, can't forget about
Kurtzon.
Kurtzon. Go to KURTZON.com, baby. That's Kurtzon.com for specification grade, man. I'm sure they know a lot about TM30 down there, but
I'm sure they're diving deep into it right now.
sure.
Getting after it.
But for right now, that's us. We are out. Thanks for listening.
Thanks, guys.